Hello. Today, let's try to solve construct binary tree from preorder and inorder traversal. Let's stopwatch start. First, understanding is essential. Let's imagine interviewer. Hey, interviewer, uh, can I ask some questions? Sure. Uh, Preorder. Preorder means parent, left, right. So parent is first, second is left, right is third. Is it correct? Yes, correct. And in order, in order means left is first and parent is second, then three is right. It's correct? Yes. Okay. And both always are the same size and consist of unique values. So every node is unique, right? Yes, unique. And just to confirm, is the solution guaranteed to be unique, or uh, is there multiple valid answers? The solution guaranteed to be unique. Okay. And base case, edge case, if preorder and inorder array, both array is empty, what should we return? Null? Yes, null. Okay. So let's think about happy pass. 3, 9, 20, 15, 7. This is happy pass. 3, 9, 2, 20, 15, 7. In order is 9, 3, 15, 27. And this is pre-order, and this is in order. Okay, plan. Understanding is okay. So next phase is plan. How to solve this problem? Pre-order first value. Let's change. Pre-order first value is gonna be root node. And it guaranteed to be root. And look at same node. In order traversal, which means left is first, second is parent, third is right. So this is parent, and this is left subtree, and this is right subtree. Left subtree, right subtree. Now, Now we are basically done with this left subtree, obviously, because there's no more nodes left in this area. And these are reserved for the right subtrees. So we can ignore uh, 3 and 9, and let's image this new tree, new right subtree. And repeating. Look at preorder first value. This is root node of the right subtree. It guaranteed to be root node. And look at same value in the in order array. It's a middle position of them. So left, right, middle. Left, right. Maybe we can recursion, because the same, we keep the same action, the same method repeating. Okay, let's implement. Let's jump into the code. In this case, we do repeating actions, so we can use recursion way. Assume that build tree function is recursive function. Recursive function needs a base case, which is exit from recursion. So end condition of recursion. So if not preorder or not in order array, return null. And first of all, preorder array first value. Preorder array first value. Preorder array first value 3 is always root node. So we make root 3 node, and what is value is preorder first value close. And we can find where the same value is in order array. Where is the same value? We can use index function. index in order dot index preorder 0 is we call middle. How to implement recursion? How to express recursion? We we attach the left subtree and the right subtree to the root node because now we have only root node. Uh, So root dot left equal and root dot right equal. And earlier we mentioned we can use recursion, so call recursive function. Preorder in order. Preorder in order. How to change preorder and in order without changing preorder and in order array? Eternally repeating, eternally recursive this. So important is, keep in mind is we separate the preorder array. We take the portion from the preorder array and in-order array. We take the same number. We take the we take the same number of elements from the preorder array. From the preorder array as the size of okay. First, let's think of starting from in order array. In this case, 3 is middle and index is 1 and we take only 9 as a left subtree, so in order left subtree portion is only 9, so mid plus 1 because in Python up mid plus 1 is non-inclusive, so actually this is 0 to 1, 0 to 1. So only 9. And how about preorder portion? How about left sub-tree preorder portion? Uh, we want to this. How to take this? We take the same number of elements. So this is on the number of element is 1. So we want to take 1. We take the same number of elements from the preorder array as the size of the left subtree we find in the in-order array. So preorder's first array, first value is used as a root node. So we skip 0. So starting at 1 to up until mid plus 1. Mid plus 1. Mid is 1. So mid plus 1 is 2. So 0, 1, 2. But Python is non-inclusive. So 0, 1. So mid plus 1 is 2, but only this node. Next, right subtree. We take the size of right subtree is 3. We want to pass after this. We want to pass after this. So mid plus 1. Starting at is mid plus 1 is inclusive. So mid plus 1. Go until end. And in order is same. Mid plus 1. Starting at mid plus 1. And finally, return. We already make root node, and we attach left subtree and right subtree. So we return root node. That's it. So let's check my code, review, and evaluate phase. Base case, if not preorder or not in order, return none. Yes, already we asked to interviewer this question. And next line, root equal 3 node, preorder 0. Root equal 3 node, preorder 0. So yeah. Anytime, always preorder array's first node, first value is root node. So it's okay. And mid equal in order dot index preorder 0. So we want to find same value preorder 0. So we can use index function. And we make left subtree and right subtree. So we can use recursive function, build tree, and in Python, we can use self dot build tree, and we pass preorder starting at 1 because preorder 0 is root node, so we skip 0 and starting at 1 to mid 1. Mid 1 is the mid 1 is with the number of elements from the preorder array as the size of the left subtree we found in the in-order array 1. And in order is starting at 0 to mid until mid plus 1 because mid is here. And we make right subtree. We call self recursive function preorder mid plus 1 because after this, and in order mid plus 1 because after this. And finally return root node. Let me check time complexity and space complexity. Time complexity is time complexity is we traverse n times the number of every node, and index function takes O n, so O n times O n equal n squared. And how about space complexity? Space complexity is the depth of recursion. This is recursive function. So depth of recursion is gonna be n. That is number of nodes. So big O and linear time. This is bottleneck. If the length of preorder and in-order array is pretty big, this algorithm is too heavy. So we should make another plan, but constraints is starting at 1 until 1000. So maybe it's okay. I forgot to run this code in the Meet code. Let's run. Accept it. Thank you for watching.